Hello everyone. I'm pleased to be again this year participating to this startup stage. And I'm François Macary. I'm the architect of the Semantic mapping services platform, which is operated by the startup Use and Share based in Paris Santé Campus. And this talk acknowledges the need for standardizing healthcare data for the training and also for the run of AI algorithms. And I will present a global map of standardized vocabulary for health, which can be of some help to that purpose. So big data is already present, of course, in the healthcare sector. This list has no pretension of comprehensiveness. These are just examples. Machine learning has proven useful to interpret images produced by a medical center, as well as photos captured by smartphones or whole slide images produced by digital pathology. Large language models are capable of finding patterns in unstructured textual reports, either written or dictated. And last, structured symbolic information is used both in classic expert systems as well as in AI-driven algorithm. And there are applications for all these kinds of AI in healthcare, in clinical decision support, for the clinical documentation of care to improve the coordination of care, and of course in medical research. It's important to note that structured symbolic information is also present as metadata attached to textual report as well as to attached to images. Therefore, symbolic information is present in all situations where AI is involved. Even though structured symbolic information is available in smaller amount than textual data and images, it can be still big data, which is provided by multiple sources. And of course, for this to be workable, all those multiple sources have to provide it using the same language, which means using a common data structure to provide the symbolic information and using standardized vocabularies to express this information. So these are mandatory conditions. If you were there this morning, it was already expressed. The problem is which vocabulary to be chosen, depending on the use case, because there are dozens of them available for the healthcare sector, and each one serving a specific set of use cases. For instance, MEDRA is mandatory to report adverse events to the healthcare authorities. CCAM is mandatory to report and to bill healthcare activities. ICD is used to report the mortality and morbidity statistics to the WHO. There is ORPHA, which is key to access the ORPHANET knowledge database on rare diseases, which we talked about this morning, and LOING, which is a terminology of observations, very much used in many countries, and SNOMED-CT, which provides a concept for all clinical information for human health. And each of these vocabularies has a set of distinctive characteristics, its names, who distributes it, what is the licensing scheme, what are the languages supported, who maintains it, what is the frequency of maintenance of new releases, where is it mandatory in a country at European level or even at the world level. So all these characteristics are captured in a map, as we will see. And to make things even somehow more complex, many vocabularies have overlaps, semantic overlaps. In particular, Snowmelt City, which is the broadest one, has overlaps with almost all other vocabularies available in the healthcare sector, like the examples which are shown here. The best situation when you have overlap between two vocabularies is when there is a concept map which is available and which is maintained and which enables to convert from one vocabulary to the other. For instance, the concept of COVID-19 in Snowmelt City can be converted to the ICD-11 RA01 code to report morbidity statistics to the WHO. So for the stakeholders, it's useful to have a clear view of what are the vocabularies available and what are their semantic positions and the use cases that they are suitable for. And the map that we have built at Use and Share provides this clear view, positioning all the vocabularies, showing the overlaps and the characteristics of these vocabularies. The map is viewable and importable as a semantic graph of nodes and arcs. And this is the high-level view of the map when you reach our platform. And what it is, it's a graph of over 500 nodes, some of the nodes representing vocabulary properties, while the other nodes represent the vocabularies themselves. And there are more than 1,200 arcs between those nodes, which represent the predicates of linking the vocabularies to their properties or linking a property to a parent property. So you see that it's quite big. It looks like a jungle at first glance, but then you can zoom. So for instance, you can zoom on a property and see what are all the vocabularies which have this value or property. For instance, on the picture here, what are all the vocabularies available in French language? Conversely, you can zoom on the vocabulary. Here, zoom on the CCAM, and then you have a subgraph showing only that vocabulary and its properties. And here you can see, reading the graph, that CCAM contains codes to represent healthcare acts. It is a vocabulary of type classification. It is available only in French language. It is mandatory in France, and it is operated by CNAM-TF. And then in the box below, you have further details like what is the organization distributing it, where are the access points, what is the licensing, what is the last release, when was it released, and where is it mandatory. So this map of healthcare vocabularies is represented as a graph. It's stored in a graph database, and it can be imported in the RDF framework. It's relying on RDF and all the associated standards, one of them being DCAT version 3, which is strongly supported by the European Commission to represent catalogs of data sets. And this map is a catalog, and it is represented by an instance of a resource DCAT catalog. And then each vocabulary appears as an instance of a resource DCAT dataset. The map is available on our platform freely. You will just have to create an account if you want to see the full map. And we welcome your comments to help us improve this work, which is still in progress. Thank you.
It's a very open question. What is your take on the UMLS based on your study?
Yeah, UMLS is part of the map.
Okay.
It's the meta-thesaurus UMLS and also the semantic type network of UMLS are part of the map. And all the vocabularies are in relationship with it.
Okay.
Thank you.